Every time we've talked about a vector so far, we've set up a set of axes where we define our x direction and our y direction. And then we have a vector v whose components are written in terms of vx, x hat, and vy, y hat in 2 dimensions, right? And vx is the x component again, and vy is the y component. But what if I draw another set of axes? Who said that I had to choose the x and y that I've been choosing? So I can choose a set of axes s hat and t hat. Is it possible to say that v is vs s hat plus vt t hat? And the answer is yes, you can. You can in fact do that, which in this case would make this vt and this would become vs. So you actually can do that, and it gives you the same vector v. But what we notice is that now if we had this initial angle between v and x, that's going to be much different than the angle between v and s, right? But what if I take it even further and I say, okay, I want to have a vector that a direction I'm going to define as a hat, and perpendicular to that is going to be b hat. So is it possible to write that v is just the magnitude of v, a hat, because a hat I'm choosing in the same direction of v, or in other words, a hat is equal to v over the magnitude of v? And the answer is yes, you can do that too. And because you can do that, anytime you only have a single vector, that's almost always going to be the easiest direction to choose. And so you'll want to set up your coordinates so that the a hat direction is the direction that you're using. For example, let's say I have a ball that's rolling down a hill. And again, if this is my x direction and this is my y direction, and then I have a ball that has some velocity going down the hill. So I could write v in terms of vx and vy, but then the entire time vx and vy are both changing, and it can be very difficult to describe the motion of v, because at each, as we'll see, that the acceleration due to gravity is going to cause it to speed up, right? We know this. Whenever you fall, you fall faster and faster and faster. And so because of that, this v is going to be constantly changing, and we have to worry about changing x component and a changing y component. A much easier way to do it is to say, let's take our a hat direction, and let's say that we're going to move the ball in that direction. So now v is in a single direction. It's not changing directions at all. That makes this problem much easier to calculate. So when you only have a single vector to work with, you should almost always align your frame of reference with the direction of that vector, so that it's much easier to write down, and it's going to be much easier to do your calculations. So that pretty much wraps up vectors and wraps up chapter 2. You should now be able to work all of the chapter 2 exercises, all of the chapter 2 problems in your textbook. In the next chapter, we're going to actually start to get to physics now. So we're going to start to talk about one of the most important conservation laws of all of physics, the conservation of momentum.